So for those of you who aren't really math people, you're not really a big fan of math. So far, maybe this class seems okay because there's not a lot of math. Today, on this page, we're going to add a little bit of math, but it's not crazy math. It's none of this, not like in algebra or pre-calc or calculus where there's more letters and symbols than there are numbers, you know. We're not going to do any of that stuff, so don't worry. But we're just going to kind of review percentages because a lot of times we talk about statistics and probability and we use percentages or fractions to represent probability and statistics. So we're just doing a little review. This is stuff you've probably learned before, but it's worth reviewing that way, you know, we're all on the same page when we talk about it. So just a little bit of review here. We're going to start looking at this part. It says percent means per 100. So that's why when you say like 10%, that's 10 out of 100 kind of thing. Percentage describes a number as a fraction out of 100. So yeah, like we were mentioning, for example, 10%. If someone said, okay, 10%, why can't my pen use, anyway, pretend like that's a percent sign, I guess. 10% is the same as 10 out of 100 as a fraction. So you can always represent a percentage as a fraction if you wanted to. And if you remember your math, that can even be reduced as a fraction to 1/10. Because what divides into 10 and 100 is 10, and then 10 goes into 10 once, that's the numerator, and then 10 goes into 100 10 times. So here's an example we have. Use hip girth to define large size. What the hell? Where'd we get that? Anyway, sorry. Excuse my French, please. Recall the data set of hip girths for 507 adults who exercise regularly. Recall. Okay. If we use hip girth to define size, 58 out of 507 adults wear large size sweatpants. I feel like hip girth probably depends on if you've had a kid or not too. Anyway, let's calculate the percentage of adults who wear large sweatpants. That's an interesting one. Okay. So what we would do is we take the numbers that they gave us. Okay, there were, let's see here, there were 58 adults out of the 507 adults who wear size large. So we just make a fraction out of that. Kind of going backwards from what we did over here. Like if it was 10 out of 100 people wear some other, I don't know, some other size sweatpants, or even another scenario, then you can reduce that and simplify it down to a percent. So over here, we're just kind of going backwards from that. Let's see. So we took 58. There were 58 people out of the 507 who wore a size large sweatpants. And any fraction you can think of as a division problem. 58 out of 507. Kind of think of it as division. I don't know why this pen won't let me do the division sign. Okay, pretend like that looks like a division sign, please. Divide those. And you'll get, like they said, 58 on your calculator divided by 507 is 0.114. I don't know why I can't make a little dot, so I'm make a big decimal point here. 0.114. Then the next step would be to multiply by 100% to convert the decimal to a percentage. Because right now, what we were given, or what we found when we divided, was 0.114, but that doesn't seem like a percent. That doesn't feel right. But all you have to do is multiply that by 100. And really, multiplying by 100, you just move the decimal point over to the right twice. So instead of actually taking your calculator and multiplying by 100, or, you know, thinking too hard about it, just take your 0.114 and move that decimal point to the right twice. Move it once to get between the two ones, and then move it once again to get between the 1 and 4, and then you have your percentage. Now it's 11.4%. So instead of saying there were 58 out of 507 people who wore the large pant size, you could say there were 11.4 people out of 100, sort of. That's another way to say it. Yeah, since 11.4 is 11.4 out of 100, we can interpret 11.4% to mean the following. For every 100 adults in a data set, 11.4 will wear size large sweatpants. Now, obviously, I don't know how you can have 11.4 people. That's like 11 people and a half of a person. But that's such things happen in statistics. That's just kind of the nature of it when you do math with people. Like I remember they used to say the average American household has 2.5 kids or something like that. Or was it 1.5? I can't remember. And I used to wonder, how can you have 0.5 kid? Is that half a kid? But yeah, that's because I didn't really understand statistics, I guess. So now let's see. Now we interpreted the results. So now the general steps are, just to review, we want to identify the appropriate ratio. So think about what's the number you're looking for? In this case, we were interested in the number of people that wore size large sweatpants, and we found that there were 58 people. So we had identified what we wanted, kind of what we wanted out of the total, and then also identify the total. You can think of a ratio as a fill in the blank. Like they kind of describe here. Let's see, a part out of the group. So we had 58. That was the part we were interested in out of the whole group, which was 507 people. The part is often a subset of the group, which is just a small part of the group with a special characteristic that we're interested in. And then we'll calculate the percentage by just taking, see, this is, if you feel like, I'm not really a math person and I never like percentages, or you're kind of hesitant about this kind of material right here, you could, if you wanted to, kind of write this little formula on your note card, but if you feel comfortable with percentages, then you're probably fine. But the one I'm highlighting in yellow here, just the part divided by the group size, and then multiplying by 100. That's what we need to do to figure out the percentage. And then we will interpret the percentage in context. Just kind of reiterate, if someone's reading this, if you wrote a paper about this and you're coming up with a percentage, you got to kind of say what it represents. So we interpret the percentage in the context. For every 100 individuals in the group, the percentage number with the percent sign will have the special characteristic. You can also interpret the percentage as percentage of the group has this special characteristic. So in our case, it was 11.4% of people that were surveyed, I guess, wore a size large sweatpant. That was the special characteristic. Now let's practice. It's your turn. So if you want, you can pause this video and try it yourself. Maybe that's a good idea. I would pause it here. Just try what's below yourself, this last little paragraph. Try the math yourself and then unpause and check. But I'll go ahead and do it now. Either you just don't feel like doing it, or you feel like it's too easy, or you actually did it and now you're listening. From the data set of the same number of people, the 507 adults who exercise regularly, 61 had a hip girth of 105 centimeters or greater. What percentage of adults have a hip girth of 105 centimeters or greater? So let's practice that. Now it's kind of the same calculation, but instead of the numerator of my fraction being, what was it before, 58? Now we're looking at 61, so we'll try that. Let's see. So we got 61 out of the same total. We're still talking about the total number of people, 507 people that exercise regularly. So I'm going to divide those two numbers, 61 divided by 507. Okay, I'm going to grab my calculator here. Let's see, 61 divided by 507. I'm getting, it's a decimal that goes on for a while, so I'm just going to kind of round it. It was about 0.1203, something like that. And then if you multiply by 100, let's see, multiply that number that we just got when we divided on our calculator, 0.1203 by 100%. That should be it. And in other words, like we said, you don't really need to multiply. You could just move the decimal over. If I move that decimal over twice, I'll get 12.03%. And that one, I mean, I feel like you could probably just round that to 12, but it probably depends on the context, how specific you want to be. That's about 12%, but sometimes they want you to be more specific. Like, I want to be very precise. I want 2 decimal points accuracy, so keep that 0.03. Yeah, it kind of depends, I guess, if whatever you're asked to do in the problem.